Okay, yeah, welcome back to my YouTube channel. So we are back with what our series on differentiation, and we are working on implicit method of differentiation. Hope you know there are some problems that you can't, or functions that you can't differentiate. You can't differentiate them. It's impossible for you to differentiate them using general methods. What I mean is that there are some functions that cannot be expressed in terms of only x, where y is lying as the subject and is expressed in terms of only x. There are some functions that cannot be expressed like that. So we say implicit differentiation method is used to target functions that are defined in terms of x and y. So these functions that cannot be expressed explicitly, are you getting me, in terms of only x, we use implicit to differentiate them. So take for instance, someone who is fighting a war, maybe a king that is fighting a war. It's easier for the king to fight the war when he or she has, enemies that are outside his kingdom. They are coming, maybe they have a set time that there is the war we hold, and they are coming, they know the boundary. It's easier. But it's quite very difficult if the king has to fight enemies that are within his own kingdom. Maybe his allies or whoever that are within, his chiefs. It's quite difficult because they are within the kingdom. So that is how this kind of functions are. So there are functions that are expressed in terms of x and y, not just only x. So we can have an example. But before we go into these examples, there are also some functions that look as if you can't express them, but actually you can express them. Let's see a function like this. If I have y cubed plus what? X, y equals what? Y. This function looks quite scary, as if it can't be expressed. But you can pause it and try it out. If you are able to solve it correctly, you should have what? What should we have? That y is equal to what? I think square root of what? 1 minus what? X. So this is what you will have, right? So if you differentiate this, you should have your answer as dy dx. Okay, it's 1 plus x, right? 1 plus x. So if you differentiate this correctly, you should have, by implicit differentiation, by chain rule differentiation, you should have 1 plus x to the power of half, because that's the meaning, right? Differentiating by chain rule, there is something you get. What will you get? First, write down the power, which is 1 over 2, right? Then differentiate the term in the bracket, you have 1. Then rewrite that term in the bracket and reduce the power by 1. So if you have not watched my video on what chain rule differentiation, ensure to do that. So chain rule differentiation will help you. So what we did is what we call chain rule shortcut. You can watch it to look up the shortcuts to applying chain rule. So this is what you get. So though even if you use implicit, you will still arrive at the same answer. So that's one example of this. Now let's see another example of this kind of question, of this kind of problem. Now if we have x squared plus 2xy plus x cubed equal 10. Again, this looks like an implicit differentiation question. You can actually use implicit to solve this. But even if you don't use implicit to solve this, you still get y to be in terms of x. Right? So what will y be in terms of x? If you solve this, you can pause it, try it out, and we'll check out your answer. So in terms of y, what will we have here now? What are we supposed to have? 10 minus x squared minus x cubed divided by 2x. That's all right. So how do you do that? Take this one over to this place. Take this over to this place, right? Then divide both sides by the coefficient of what? Of y, which is 2x, right? 2x. So now if you want to find dy dx, it's quite simple. Because this thing that is looking very big can be broken down to 10 over 2x minus x squared over 2x minus x cubed over 2 x, right? Which will give you, if I break this down now, I'll have what? I'll have 5 over x, because 5 can go here, 2 can go here 5, 2 here what? 1. So minus x will remain over 2, because one of the x will go with this. Then minus one of the x will go with this, it will remain x2 over what? This. So if you find, now this is y. I just made it to look more what? Simpler. So find dy dx. What will it give you? It will give you what? If you differentiate this, it will be minus 5 x to the power of minus 2, because this is x inverse. I can write this as 5x raised to the power minus 1. So if I divide it, the minus will come forward, right? Then the power will be reduced by 1. Now this is minus, if I do the same thing for this, what will I get? I'll get half, right? Because this is half than x by the side, right? This can be written as 1 over 2x. Then doing the same for this, I'll have minus, this is the same thing as saying this is 1 over 2, x raised to the power 2, right? But if I differentiate, because I'm just writing the normal form, right? If I differentiate, it will be the 2 will multiply the half, right? Then x to the power of 2 minus 1, right? So have 2, we cancel 2. So at the end of the day, we'll have minus 5x to the power of minus 2 minus 1 over 2, then minus x to the power of what? Of 1, which is tx, right? So you can further simplify this if you want, or leave it this way. So if I want to further simplify it, I can have minus 5 over x squared minus x minus 1 over 2. I think it's preferable this way. Or I can still factor out x and have, I can factor out x squared, right? Or I can say, if I multiply through by x squared now, what will it be? What will it be? So if I have this as minus x squared, open brackets, what will it be? Or let's just have minus 1 over x squared, right? This is 5, right? This will now become what? Minus. So what will multiply by this so that we'll have x remaining here? I think x to the power of 3, right? And this will be plus. Hope you know. Because this multiplied by this, minus will multiply minus, we'll have minus, right? X cubed over what? 2 squared. What will it give you? Are we following? Are we following? So minus, then finally for this we should have plus, not minus, because this is minus and we have factored out minus, right? So from here, there's a way, wait. We have x to the power of what? To the power of 0, right? I don't think there is. It can also be x squared over what? You know, this can be 1 over 2 x squared. If I multiply this by this, what will happen? It will be half. It's correct now. This multiplied by this, what will it give you? Let's just be plain. Minus times this will give you plus. Yes. Then this times this will give you x. It will give you this, right? It will give you exactly this. Let's just look at it, 1 minus this multiplied by 1 over 2 x squared. Is it not what we're looking for? This multiplied by this, what will it give you? Minus. Then this is just a constant. Constant can be in front, so you have 1 over 2. Then x. You know this is inverse already, safe. That is minus 2 plus 2. To give you 0 now, this is correct. Is it not? You can leave this as this. But preferably leave it as this. You don't need stressing yourself over it. So we are here with this question. And this question is purely implicit. Why is it purely implicit? You can't make y the subject of formula here. Like, you can't express the function in terms of purely what? X. What you mean expressing the terms, it looks like big grammar. When we say expressing in terms of purely x, we say you can't make y the subject of formula. So that everything on the other side will now be what? X. You can't do that. If you try doing that, you have a kind of function that will end up looking like an algebraic equation, which you can't differentiate, right? Because you have plus and minus a function that is in terms of x, and there is square roots. So it's looking very, very what? Ambiguous. It's looking very what? Ambiguous. So, but there is something we can do. We can apply implicit. So what is the method of this implicit? So this implicit tells you that if you have this kind of problem, which you have x and y scattered all over the place, what you do is what? You take the general method concepts. That's why I say, in as much as you are not using general method here to differentiate completely, you are still applying the concept. The what? Concept. So what you do is you differentiate everything term by term. But when you have y, since you are not differentiating with respect to what? To y. You are differentiating with respect to x. Hope you know. Anytime you differentiate y, you add the y, the x by the side. That's just the what? Idea. Hope you understand. So now, if I'm differentiating this, now any place we touch y, we have what? We add the y, the x by the back of it. Now again, what you should take note again is that whenever you have x and y multiplying itself as a term, as a what? Term. Whenever you differentiate it, you apply product rule there. You apply what? Product what? Rule. Let's go. Let's try this and see more examples. Now looking at this, now we'll come here. Solution. 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 Step 1. Step 1. Differentiate the function, or in this case I can say equation because we're having equal to 0. Equation. Term by term while what? While attaching dy dx to any derivative with respect to what? To y. Or let me just call it the the what? The dependent variable. Why do you think I call it dependent variable? Why do you think I call it dependent variable? The reason is because it might not be y. It might not be what? Y. Hope you know. I can give you another implicit differentiation. There is no only x and y. There is no only what? X and y. It can be u and v. It can be what? U and v. It can be any other thing. So let me not just restrict it to what? Just y. So can we apply that? Can we implement this step 1? So step 1, let's implement it now. If you want to differentiate this by your normal general method, what will it give you? So what? By step 1, we have differentiating this will give you what? 2x. Then plus 2y. Do I end here? No. I'll attach dy dx to it. Minus what? 2. I differentiated this in terms of x and this in terms of x. That's why there is no dy dx. Hope you know. Okay. So for here now I have minus 6 dy dx. Hope you know. Then plus 0. Because whenever you differentiate a constant, we have been saying it from what? The onset in general method of differentiation. Now whenever you differentiate a constant, you always have what? 0. It must not be numbers. It can be a or b. It can be other things that are not what? The known variables that we know. You understand? So that's it. To give you 0. Equal to 0. Even if I differentiate 0, I will still get 0. Right? So from here now, what will be my next task? Step 2. Step 2 says that you should what? Collect like terms, collect like terms and make dy dx subject of what? Of formula. Of what? So what we are doing is to what? It mustn't be collect like terms anyway. It can be manipulation as the case may be. That's why I say in this case now we are using this step based on this question. Based on what? This question. But for any other question, just manipulate it and make sure what? That dy dx is the what? Subject. Is the what? Subject. So we have here now, if you collect like terms, what we have? We have 2y minus 6 into dy dx. Right? Plus 2x, right? Which is this. Minus 2 equal to what? 0. Right? We picked out this, right? And we merged it. Because they are of the same like term. And we factor out dy dx, right? Then we now brought this and this over to this other place. They have not yet crossed the equal to sign yet. We are just collecting like terms. Now in this case, now we have 2y minus 6 dy dx equal, taking this over to this side, we have minus 2x plus 2, right? So we can divide both sides. Divide both sides. I can write it somewhere. Let me write it. Divide both sides by 2y minus 6, which will give you dy dx equal to what? Minus 2x plus 2 all over 2y minus what? 6. And that is the what? The final answer for this problem.